And we're here on behalf of WBUR, which I just want to say one more time is really proud to be a part of the Martha's Vineyard Book Festival. So Peter has written this book about the mass extinctions that the world has seen. It's called The Ends of the World. And we're going to get right into it. And I want, Peter, for you to just, first of all, briefly tell us about the 5 mass extinctions in Earth history.
Okay, so my story picks up around 500 million years ago. The first 4 billion years of Earth history. A lot of paleontologists would tell you there's nothing more interesting going on than pond scum, so we can kind of just forget about that. But then in the last 500 million years, you have animal life sort of explodes 543 million years ago at the beginning of the Cambrian. And then since that time, there's been 5 times where, in a pretty brief period of time geologically, over 75% of animal life goes extinct. And so these have kind of been a mystery in paleontology for a few decades, and paleontologists are starting to put the pieces together. And so I'll just go in order. The first mass extinction, 445 million years ago, is the End Ordovician period, or the End Ordovician mass extinction. The Ordovician is a totally different world than we're familiar with. The continents were in completely different places. South Africa was over the South Pole. North America was rotated 90 degrees and straddled the equator and was mostly covered by a shallow sea. There was no life on land whatsoever, except for some tiny little plants around lake margins. But for the most part, it's just a desolate world. And all the action is going on in the ocean, where it's this kind of bizarre invertebrate bug world. So the planet's dominated by things that would look like trilobites, kind of, and these giant squid-like animals that are in these giant cone shells that were some of which got to be 20 feet long. There were sea scorpions that were the size of a human. It's this really bizarre world. And there are actually fish, our ancestors, but they're kind of small and jawless, and they're kind of like staying out of the way from all these giant other things that are dominating the ocean with shells and tentacles and sort of this weird sci-fi world. And then the Ordovician is pretty quickly destroyed right at the end, and it's pretty obvious that there's this major ice age in Africa, which is over the South Pole. We know this because you see the exact same sorts of glacial features that you see in Maine and New Hampshire, only they're in the middle of the Sahara Desert, and they date to 445 million years ago. The glaciation is thought to be caused by... So today we're worried about CO2 going up too fast, and if CO2 plummets, instead of getting very warm, it gets really cold. And so something was sucking down CO2 at the end of the Ordovician. And the explanation that at least a geologist I talked to in the book, this guy at Harvard, thinks it's driven by the creation of the Appalachian Mountains in the tropics, which, for reasons that I get into the book, but I won't here, would have been capable of drawing down tons of CO2. So you have this major...
They were much bigger than they are now.
Oh, yeah. So they would have stretched from Greenland to Alabama and been as high as the Alps. And in the tropics, you'd have a lot of weathering of the rock, which would be drawing down CO2. So that's kind of a strange one. 100 million years later, you have the Devonian mass extinction. By now, fish are dominating in the ocean. Trees are just starting to come onto land, and some fish are actually trying to come onto land as well. These, again, would have been our ancestors. But the fish that are dominating in the ocean are these really strange armored sort of tanks. Some had these, these self-sharpening guillotine blades for mouths, and had these big bony helmets, and they're fish, but we wouldn't recognize them as such. The world's largest reefs in the history of life on Earth, they would have been 10 times bigger than today's reefs. 99.9% of them get destroyed in this mass extinction. All these bizarre fish take a huge hit. The few fish that tried to go on the land, most of them were wiped out. So interestingly, these fish that came onto land, a lot of them had 8 fingers on each hand, and only the ones with 5 fingers made it through because every subsequent vertebrate has 5 fingers. So you can thank this extinction for the fact that you have five fingers.
And what caused the extinction the second
time?
Oh,
yeah, okay. So interestingly, trees, the evolution of trees really would have disrupted life on Earth, it's thought. So all the shale that we frack today in the Midwest is from when these shallow seas that covered the Midwest lost their oxygen and all the life died, and over 370 million years has become fossil fuel, basically. But it goes to this extinction. Trees would have been pouring all these nutrients that would have fueled algae blooms, that would have robbed the oceans of oxygen. We see the same thing today with polluted ponds and in the Gulf of Mexico, which has a lot of, nutrients pouring in from the agricultural heartland is fueling these big algae blooms, which dies and creates this huge dead zone today in the Gulf of Mexico. The same thing would have been happening in the Devonian, but on this massive scale. There also is a huge volcanic event that seems like it might have been around the same time. And
which pumps carbon into the atmosphere.
Which might have driven global warming. So everything's going wrong. There's all these invasive species that are invading and sort of wiping out native species. And the period ends with another big mass extinction that's an ice age that's probably caused by trees sucking so much CO2 out of the air. Okay, so the first two are kind of weird. The next three kind of have a unifying element to them, which is volcanoes, as you said, which would have caused climate change. So 100 million years forward in the future, we're now in the Permian. Life has come onto land. There are trees and forests. There are big animals that walk around. In the ocean, reefs have sort of rebounded. And then there's the single worst moment in the history of life on Earth, which is the end Permian mass extinction, where 90% of life on Earth gets wiped out. And the fossil record sort of goes silent for a while, and reefs are replaced with bacteria. You see these bacterial mounds instead of where coral reefs were. Vegetation was so destroyed that rivers stopped winding. Because that's how rivers wind, because vegetation holds back the banks, and you can actually see in the geological record, you see these just
straight rivers,
braiding straight rivers. Yeah. So at the same time, so this was long thought to be caused by an asteroid strike, just like the dinosaur extinction, but geologists went looking for the same sorts of things, like asteroid dust or a crater, and they couldn't find it. And instead, they found this gigantic volcanic province in Russia, in Siberia, that would have erupted enough lava to cover the lower 48 states in lava a kilometer deep. So it's not things like Yellowstone, which we talk about today, which would be devastating for civilization, aren't even worth talking about in the same book as this volcanic event. But interestingly, it's not the lava that's thought to cause the extinction, because that only happens in Siberia, and everything at every pole all over the world goes extinct. And it's thought that it's the gases that this volcano would have been capable of producing basically just made the climate and the ocean chemistry haywire. It injected a ton of CO2. It gets incredibly hot. You can see ocean acidification in the fossil record. So ocean acidification is what happens when too much CO2 reacts with seawater. It makes it more acidic, and it makes it hard for animals to build their skeletons. This is something that we're starting to see in today's oceans. As I said, it gets really warm. One paleontologist put it to me, it got the temperature of hot soup over most of the world. So a very unpleasant place to live.
So that's three.
That's three.
There's still two more extinctions.
Two more. 50 million years later, there's the end Triassic, but it's basically the same thing happens again. There's this gigantic volcanic event. You can see the remains of this in the Palisades in New York, which is basically if you see it today, it's this giant wall of what was once magma that fed these huge eruptions that actually made the Watchung Mountains in northern New Jersey. So the Watchung Mountains were these ancient eruptions. And you can find the same rocks in Brazil, Nova Scotia, Europe. So it's this globe-spanning, crazy volcanic event. It does the exact same thing as the Permian: global warming, ocean acidification. This alternate universe of crocodile relatives goes extinct. Coral reefs basically disappear again. Actually, the Alps in Austria and Switzerland, it might be Switzerland, but definitely in Austria, are made of these coral reefs from this period that go extinct. And then 135 million years later is the most recent extinction, the one that everyone knows about, the big dinosaur extinction. The biggest asteroid known to have hit our planet in 1 billion years hits. Interestingly, at the exact same time that in India, there's another one of these major volcanic events. So for the past 30 years, there's kind of been these two warring camps debating whether it was the asteroid, which is kind of won over the popular imagination, or whether it was this volcanic event, which we know is capable of producing mass extinctions. And interestingly, there are other times in Earth history where big asteroids hit and nothing goes extinct. So that's
well, and as you were talking about with the Siberian situation, the asteroid would not necessarily impact all life across the entire planet.
Yeah. Well, so that's what some skeptics would tell you. But other people have done calculations that show that the asteroid would have ejected so much rock that would have taken these, gone into orbit and then come back into the atmosphere and heat up the atmosphere to what someone compared to it would have been like a broil for 20 minutes. So that's why people think that mammals might have survived by burrowing, and maybe these birds that had these dwellings in cliffs might have survived. But some people are skeptical whether it was that bad.
So how close are we right now in terms of carbon emissions to one of these massive volcanic events? Can we do that ourselves and cause a mass extinction?
I think that's still an open question, and why I think it's urgent to be studying these periods in Earth's history, because some geologists would tell you, no, these are such extreme outliers that we don't really have to worry about it. As one example, I think if we burned all our fossil fuels, it would be something like 5,000 gigatons. And estimates for the end Permian amount of CO2 going into the air is 10 to 40,000 gigatons. So way more than we could ever emit. But the concerning thing is, for things like making the ocean more acidic, it's actually the rate that matters more than the total volume. And so the end Permian played out over tens of thousands of years. We could do in the next century sort of the same thing to the chemistry of the oceans that the Permian did.
Well, one of the scariest things I have to say in your book to me was when you talk about the coral reefs and what a role they played in previous extinctions. And, we've been doing stories on my show every couple of months about how they're discovering that half of the Great Barrier Reef has been bleached. And it's, because the ocean temperature has risen a few degrees.
Right. Yeah, I think if more people knew the status of coral reefs in the next few decades, there might be more urgency with regards to our energy system and emissions. Because if you plot out anything like business as usual, even to mid-century, it's starting to look like the oceans aren't going to be a very healthy place for coral reefs to live. And coral reefs supply 25% of the ocean species. So then we could start to, we're not at a mass extinction yet, but once you start knocking out things like reefs, those are things you do see in the geological record associated with these things, these horrible events. So yeah, I think we need to make some changes.
Do we know how long the mass extinction takes to occur? I mean, is it 1 million years or is it, 5 days?
Because the geological record is kind of hazy. It's hard to tell with really fine resolution how long these things are playing out. So some people would tell you the dinosaurs went extinct in 15 minutes from the asteroid strike, and other people would say it took over 50 to 60,000 years, and that was just one part of the things going wrong in the environment. So we don't really know, which is another reason why I think it's such an urgent thing to be studying, because maybe these aren't good comparisons for what we're doing. Maybe they're just too out there and too extreme. But on the other hand, maybe we'll see that it's actually the same time scale and it's comparable to what we're doing today.
We were talking about carbon. You also write in this book that nitrogen is a big problem right now.
Well,
are nitrogen emissions?
Yeah, well, no, nitrogen, it's just, rather than it being a problem, it's sort of fascinating what we're doing with nitrogen. So basically, human beings up until the early 20th century were only able to plant as much, grow as much food as was available with, manure and those sorts of sources of nitrogen. And then the Haber-Bosch process was invented, and suddenly we synthesized biologically available nitrogen from fossil fuels, and now we can just. That's why the population spikes, and we're adding 1 billion people every 10 years, is because we were used to be limited by how much fertilizer we had on the planet, and now we can just make as much as we want, and there's a lot more people. I'm probably here because of that invention, and most of you probably are too. So,
and how does that feed into what we're talking about? I mean, does the fact that we're doing that put us at risk?
Well, it just means that we can grow a lot more animals, which emit a lot more methane, and have a lot more people who burn a lot more carbon, and so people debate what the carrying capacity is on the planet. Some people would say we can support billions more. Some people would say we're already too many, but we've kind of just destroyed that limit with our ability to grow as much food as we want, basically.
You mentioned the Palisades in New Jersey, which probably surprised a lot of people that that's a really important
Right.
place of Earth's history, but a lot of the places that you went to see evidence of all of these moments in history are like right here.
Right.
They're in the United States.
Yeah, that's something I kind of wanted to illustrate with the book, is that you don't have to go to the Southwest to find great fossils. There's incredible geological stories just that surround you, no matter where you are. If you just find a USGS report about whatever rock you're standing on, it tends to have an amazing story. So growing up in New England, I always thought granite was just kind of boring, and I kind of wish that I lived in the Southwest and could look for T-Rexes and all that cool stuff. But then you learn the story of it, and the granite is for the most part, from a volcanic island chain that rifted off of near the South Pole 500 million years ago, and then crashed into the east coast of North America, which is in the tropics 440 million years ago. So I think I like the subject because it's sort of, elicits the same feeling as when I read about sci-fi, because you just have to imagine these worlds that don't exist anymore. I wrote a story for the Martha's Vineyard magazine that's coming out soon about the Gayhead Cliffs and the geology of that, because I was always fascinated by what these clays were, and it turns out they are from this river delta in the age of dinosaurs, and they have the world's oldest fossil moth egg in them, which is kind of cool. And when you see there's charcoal, there's a layer of charcoal in it, and that's actually from forest fires from dinosaur times. And so people just throw it on the fire. They don't realize they're throwing, charcoal from dinosaur times on there. So, and in fact, you brought up the Palisades, which it's this magma from this mass extinction. They did a drill core in Nantucket, and when they drilled down, they actually hit the Gayhead stuff. But then below that, you hit the Palisades magma there too. That's the bedrock there, is from that extinction as well. So, yeah.
How difficult is it when you're going to some of these places, and you went somewhere in Texas, and to see them now and imagine what they were like then, or be able to make the connection? Is it obvious?
No, you sort of need this lens of geology. You need to learn it to sort of reconstruct these things. One of the places I visited in Texas, which was so neat because it actually didn't require that much imagination, is the Guadalupe Mountains, which are about an hour and a half east of El Paso, in the middle of nowhere. But it's a giant coral reef. And as one paleontologist told me, when you're standing at the bottom looking up at it, it's the exact same thing a scuba diver would have seen, 260 million years ago. And you can just sort of like walk up it and, oh my God, there's a sponge or a coral or a trilobite or a squid shell. So yeah, it's totally changed my worldview, sort of. Everything I see around me, I wonder what's the story behind that rock. Or
you write that we humans have cousins, so to speak, that were around 250 million years ago before the dinosaurs.
Yeah. So part of the Permian world that was mostly destroyed is this weird world of, they're called mammal-like reptiles, or Proto Mammals, but this is on the branch of our ancestors, these things that eventually became mammals. But in the Permian, they were the dominant sort of kind of life on land. There were these rhino sort of things with tusks and beaks, and there were these very athletic-looking things that vaguely look like tigers or wolves, but they're still firmly reptiles. They haven't become, as far as we know, they haven't become warm-blooded or, have any of the characteristics of mammals. And they had to get destroyed for the age of dinosaurs to get started. And one of our ancestors, a little weaselly thing, probably got through. But it's kind of weird to think that we learned the story of mammals took over after the dinosaurs, but we kind of had a shot earlier in Earth history and kind of had to wait in the wings for 135 million years till the asteroid struck to take over again.
Well, you also point out that we humans were responsible for the deaths of a ton of different species.
Yeah.
Like as soon as we moved into an area,
Yeah.
they all, and not just because of us, but because of pigs and rats and things like that.
So it's still pretty hotly contested. I think archaeologists are more skeptical of the role humans played in. So, for instance, what we're talking about is woolly mammoths and giant ground sloths and giant armadillos and giant wombats and all these things that you associate with the Ice Age seem to go extinct really close to when humans show up in a new continent. So Australia, around 50,000 years ago, lost these like rhino-sized wombats, these gigantic monitor lizards that were about 20 feet long, giant kangaroos. All this stuff disappeared, had made it through the Ice Age, and then suddenly disappears when nothing interesting is going on besides the arrival of humans. And then 12,000 years ago, around when humans came into North America, is about the same time as woolly mammoths and mastodons and giant armadillos and giant ground sloths disappear. So for geologists, it seems like kind of an open and shut case. But archaeologists like a little finer resolution, and if something's not tied to within 1,000 years, they're skeptical. But geologists, if it happens in the same million years, they think it's probably it probably has something to do with it.
Do you think we're in a renaissance of life right now?
No.
No.
Well, so there's certain reasons to think that the Earth is healthier than it might have been in some of the ancient mass extinctions. The ocean's probably more oxygenated for some weird reasons. Pangea was a really bad time for life because there, islands and disparate landmasses drive evolution and different species. And so in Pangea, you just had one big landmass, and diversity was probably lower than it is now. So there's reasons to think that our Earth might be resilient today, but certainly the influence humans have had in the past few thousands and certainly in the past few decades and going into the future, things could get pretty dicey.
How did you get interested in this?
So I kind of came at it from an environmental reporter angle where I was writing a lot about climate change and things like ocean acidification and overfishing and human influence on the environment. And the Woods Hole program that she mentioned at the beginning, it kind of came as a revelation to me that we've actually run this experiment on the planet before. And you don't just have to model climate change on computers. You can go back and look at Earth history and see what happens when you run these crazy chemistry experiments. And there's a lot to learn from it. I thought this story, I was aware that, mass extinctions are associated with asteroids in the public imagination. And I was aware that there was this cool story that was coming out of geology and paleontology about these volcanoes that are just really cool events, and sort of they deserve an equal place in the public imagination as the asteroid in Mexico that wiped out the big dinosaurs.
Is there anything that we can do to stop the next extinction?
Yeah. So all these mass extinctions wiped out 75 to 90% of life on Earth. And so far, humans have wiped out, documented, we've wiped out less than 1%, but maybe at most a few percent of species. Paleontologists who have studied the rate at which we're driving species extinct warn that a few more centuries of doing what we're doing, we could actually get into the same category as the end Permian, which is just totally outrageous. So there's still time to save the world, which is the good news. We can, vote for the people who accept like the last 2 centuries of physics and chemistry, and the conversation at science conferences is so many light years beyond the public conversation about these events. And in the book, I kind of just start by saying, all right, I don't have time really to explain like basic, like it's a given that like.
Well, I did very badly in physics and chemistry in high school, and I was able to follow along. So you did a good job of that.
So vote for. I mean, we need to kind of transform the energy system in the next few decades. There isn't really that much time to hit the Paris climate goal of 2 degrees, which, as one person put it to me, it's by the time we get close to 2 degrees, we're going to think that was crazy to aim for to begin with, because it's going to be a pretty different world. But in order to hit that target, we need to go to 0 fossil fuels by mid-century and invent these, as of yet, fictional machines that can suck out gigatons of carbon every year. So we're way off that target right now. So voting for people who will act on these issues is a big one, because power plants and burning coal is really where the heart of the matter is. More so than driving cars or recycling, it's how we power civilization is really where will make a difference. And also establishing big no-go zones like marine preserves where you just can't, you don't fish, you just let nature take its course. Because fisheries and nature can really bounce back if you give it a chance. A few decades, or 15, 20 years ago, we weren't supposed to eat swordfish. We relaxed fishing pressure, and now you can, with a clear conscience, eat swordfish, because these are things that have thousands of babies at a time. And the populations can rebound. We just need to give nature kind of a break to let it bounce back. So,
I want to just offer the chance for people to ask a couple of questions. We just have a few minutes left, but while we're waiting for that, one of the interesting things that you write about is that if we do go into a mass extinction, or at least if we start having problems, we're going to notice it from the power grid, that the power grid won't be able to handle all of our demand. Is that?
Oh, well, the power grid might be... So we don't understand why power grids collapse, basically. The gigantic power grid failure on the East Coast, I think it was in 2003 maybe,
2003,
was caused by a software bug in a control room in Ohio, I think, and it caused this cascading disaster on the East Coast. And it turns out mass extinctions might work the same way, where we keep giving nature a beating and it seems like it's taking it, and then you take out the wrong species and the whole thing could come down. So that's the analogy.
Any questions that people would like to ask? Yeah.
Just really quickly, because I think this is something probably a lot of the people in the room wonder. How do you talk to people who, as you have said, don't necessarily believe proven science from the last 200 years and are unwilling to acknowledge what can actually be proven?
Yeah. So one thing about the book in general is that I think people are more open to learn about like crazy alien worlds and weird species, and this is sort of a way into that subject that isn't as politically charged as talking about polar bears or anything like that, because everyone likes dinosaurs. So that was one thing. Another thing is, so ocean acidification, which might be as scary as global warming, there just aren't skeptic talking points about yet. So I've talked to people who just will give me the Heritage Foundation like talking points on climate change, and then I'll be like, okay, well, if you add too much CO2 to ocean water, it gets more acidic, and calcifying animals have trouble staying around. And like, oh, okay. They don't know about that subject at all. And talking about coral reefs, it's just basic chemistry. And so there really is no rebuttal to it. Global warming is basic chemistry too, but people are kind of closed-minded to that. So I don't know if that helps.
You talk about asteroid hits, and I realize the size of the asteroid probably matters quite a bit.
Yeah.
But if we took an asteroid hit in current times, what would that look like?
wouldn't be pretty. Certainly, if it was the same size as the one that wiped out the dinosaurs. There's actually a calculator online where you can estimate what it would be like from a certain distance from the dinosaur asteroid. So I plugged in the specifics for Boston, what it would have been like for to be in Boston when the dinosaur asteroid hit Mexico, and it would have been painfully loud. The sonic boom would have knocked over all the trees and all the buildings. It would have gotten really hot really fast. And I asked someone, what would it be like to see the asteroid hit? And he said, if you could see the asteroid hit, you'd be dead. Because it would be so bright that you'd just be set on fire, and so it would be pretty horrible. Interestingly, though, there is a giant crater. If you go on Google Maps and you go just over the St. Lawrence River north of Maine a little bit, you see this giant circular region of lakes. That's the Quaggan crater. It's 62 miles wide. It's almost as big as the one that wiped out the dinosaurs. And it hit 214 million years ago when nothing went extinct, really. So that's why some people think that maybe it's these volcanic events that are more devastating than asteroid strikes in Earth history. So.
Yeah, you were talking about fertilizers. I just read this article in the Times about the soil depletion across the world, and how it's going to affect civilization. And now you're talking about fertilizers, and we know that non-organic fertilizers are bad for everything. Mm-hmm. So where is this balance hopefully going to be?
Well, yeah, I think soil erosion, and there's all sorts of challenges to agriculture in the next few decades. For instance, we rely on phosphate mines in Morocco for most of the fertilizer that we use for phosphorus fertilizer. So if global relations go sour or we run out there's not much backup. But these are all things that affect civilization, and I think a lot of people confuse mass extinctions with civilization collapsing. I think civilization could collapse a long time before there's an actual global Permian level mass extinction, because the Earth, as skeptics say, the Earth has been warm before and life's been happy, which is true. But if you map on these ancient greenhouse worlds to our world with political borders and mass migration, civilization could collapse, whereas life just migrates to the poles and back again. So I think they're kind of two different issues.
On that lovely
On
note.
that cheery note.
Thank you, Peter Brannen.
Thanks.
No, I got it.